And welcome to the Daily Space Weather, folks. I'm your host, Dan, aka smAsho. Starting things out looking at the sun here in colorized magnetogram. To see a rather large sunspot rising up here in the northeast. So far it's only alpha class, and we see a degradation of the other existing sunspots down here in the southwest. We'll also be talking about filaments, as we see some of those as well, and the coronal hole that's rotating in. We've also got the colorized magnetogram and 171 angstroms composite here at the beginning of the video. Great view of that rising sunspot. To be named later, Sunspot 2811. Next, a diagram of the solar system. Here's where stuff is now. And there's where stuff will be in a week. And we'll have a gibbous waxing moon by then. And we show a star chart daily as well. There is the location of Constellations from Lehigh Valley, Pennsylvania, where we're located. And at in-the-sky.org's star chart, you can actually advance it too if you like. If you're up before dawn, you may see Saturn, Jupiter, and Mercury rising ahead of the sun. Just put in your location if you want to build yourself a star chart. And the 10.7 centimeter radial flux is about to go up. It has recently actually dipped to 75, so we see a dip in the radial flux there. And that is the radio output of the upper chromosphere and the lower corona. Just this area right here, folks, is about where the radial flux comes from, the 10.7 centimeter radial flux, the most proportional aspect of solar activity to sunspot number. So sunspot number is this red line. Here's the 1-year chart. You can find this at solon.info/solar. Radial flux down to 75. You can expect to see this tick up significantly coming soon. This black line up here is the 10.7 centimeter radial flux, and the red line is the sunspot number. And here are the graphs of solar cycle 24 and the beginning of solar cycle 25. And you can see how proportional the radial flux is to the sunspot number. And that rising sunspot group that we see is only a unipolar sunspot. So here's a full disk view. This is 193 angstroms, and we've got this large coronal hole associated with the south solar polar field, rotating into the Earth-facing zone here now. It should be sending a coronal hole wind stream to your earthly location in about 5 days. And here's a great close-up of that coronal hole region. And coronal holes are super important into the understanding of sunspot cycles in that they show us the reversal of the solar polar fields. We've been meaning to do a video specifically about coronal holes. We just haven't gotten around to it because of various other responsibilities. It's coming. And we've also got a full disk view here in 304 angstroms. And we do see some filaments to the north of this sunspot. Filaments right up in this region up here. The likelihood of coronal mass ejections up a little bit here, although not all that high. Risk of solar flares has not gone up a whole lot either. And we've moved into the Do Not Pole Vault the Caldera section of the video, where we talk about volcanoes. Today on the list, we see Suwanosejima exploding in the Ryukyu Islands. The Ryukyu Islands. And Suwanosejima producing a 5,000-foot ash plume. Semeru in Indonesia, 13,000-foot ash plume as it explodes. 20,000-foot volcanic ash plume above Popocatépetl near Mexico City. In Guatemala, we see two volcanoes. Pacayas producing a 14,000-foot ash plume, Fuego producing a 15,000-foot ash plume, Revenador also exploding, 15,000-foot ash plume there. And we're unable to detect whether or not Sabancaya in Peru is erupting. Again, please don't pole vault the caldera. If you'd like some merch that says don't pole vault the caldera, you can find it at our Redbubble shop, and you'll find links to all of that on our homepage at smAshomash.com. Everything from socks to 3 different size masks, throw pillows, comforters, duvet covers, cell phone cases, and a bunch of clothing as well. Again, you can link to all of that at our homepage, smAshomash.com. You can also find our social media links there and so on. So if you haven't checked out our homepage, smAshomash.com, there are various links in the description below the video to link you directly to our sites. And what we were showing you there is the smAsho merch page, which will redirect you to this, our Redbubble shop. So perhaps check that out. Support the channel that way if you're in the market for some merch. Maybe you'd like a Fauci Fraud bath mat, or perhaps a Smash of Hazard shirt. And moving into some geologic activity here, now we'll talk about earthquakes. And thanks for leaving comments 1 audio. Here's the earthquake report. Over the past 24, we see no major quakes. Actually, a lull in seismic activity here for the most part. And we're just going to scroll up the list. Papua New Guinea saw a 5.3. That's one of the largest of the past 24. We saw a deep quake near the Fiji Islands, a 4.6 magnitude at over 520 kilometers depth. But overall, a basic lull in earthquakes here. A 4.3 at Timor-Leste, and only 4 minutes later, a 4.4 in western South America there at Argentina. Those are both deep quakes. The Timor-Leste quake was at 415 kilometers at a 4.3 magnitude, and the Argentinian quake was at 198 kilometers and a 4.4 magnitude. So totally different depths there. Similar magnitudes detected. Only 4 minutes apart, folks. Kermadec Islands also saw a 5.2 as seismic activity simmers down there following that 8.1 quake. The volcano islands of Japan also saw a deep quake of 4.6 magnitude at 157 kilometers depth. So a downtick there in seismic activity. Let's go back to solar data. We saw one B-class flare here yesterday. Since then, only background levels of X-ray flux from the sun. No proton strikes. We would have probably let you know about that ahead of time. And the GOES magnetometer has gone into a more smooth regime here. A little bit smoother readings from the GOES 16 magnetometers. That is a 3-day chart. And let's take a look at the heliospheric current sheet. Here's the top view ecliptic plane field plot. And most of the current sheet around the Earth portion of the sun right now is South Pole oriented. So you can see this large red current sheet. And these essentially create a sandwich, folks. There really are 2 current sheets. There's always a North Pole and a South Pole one. And you're looking at just a slice of it here. And at the Earth, the Earth latitude in the solar system, you're seeing mostly South Pole-oriented current sheet in which the Earth is solidly in. And we're not expecting it to leave anytime soon. Keep in mind the data is 1 hour and 24 minutes old and can change suddenly with basically no warning at all. Here's a line of sight coronal hole plot, and you can see that large red coronal hole rotating into the Earth-facing zone. It's South Pole oriented. It shows the sun's B field also in blue. And we see a little movement here on the eastern portion of the B field. You can see it kind of being pulled up there. Or is it being pushed up there? Or is it a push me, pull you situation? And we'll also show you the LASCO C3 here. The LASCO C3 showing Venus, that very bright object, getting ready to move behind the coronagraph obscuring disk. Next, check out the real-time solar wind. It has subsided as we forecasted yesterday. I believe I said watch this to go below 500, and indeed it did, reaching lows of all the way down to about 413 kilometers per second. And we also saw a reduction of the density here, down into the 3s now, it looks like. Otherwise, pretty uneventful. We see a convergent BZ there, the BZ at 0, the top pane, the red line there, indicating a fairly equal contribution to the sun's total field by both solar polar fields. No big shifts in the phi angle either. Again, the solar wind has subsided following that coronal hole. Current solar wind conditions are about 3 protons per cubic centimeter for the density and about 421 kilometers per second for the speed. And there you can see global geomagnetism subsiding as well, having come out of a geomagnetic storm for a brief period on March 14th. Current KP index is 2. Each one of these bars represents 3 hours of data, folks. Next, we're going to show you a visualization of the magnetosphere. We show it daily. Here's the magnetosphere movie for density, and you can see that low density solar wind there from the left. It shows you light colors as low density, dark colors as high density here. This is literally protons per cubic centimeter. It's a short range, though. It's only 0 to 4. So when we see higher than 4, you see just a bunch of dark blue on the density. We'll also show you the pressure. This is in nanopascals. And you'll see a fairly low pressure here. Each of these is 4 hours of data, courtesy University of Michigan. And keep in mind, folks, this is a model based on a lot of observations. Everything from the solar wind speed, velocity, BTBZ, the pressure, the temperature, in order to achieve the space weather modeling framework. Next, looking a little closer to home here, ground magnetic perturbations. Changes in the Earth's B field, geospace delta B. So we showed you the sun's B field earlier. Well, this is the Earth's B field, at least in terms of changes to it on the ground level. And it's also 4 hours of data like the other geospace magnetosphere movies we showed. Pretty calm there in terms of changes with the magnetism. We are streaming this video live to Twitch. It's twitch.tv/smAsho. Thanks to our followers over on Twitch. And thanks again for leaving comments. One Audio says, it's not that I'm lazy, it's just that I'm lazy. I would much rather hear from you without having to do too much research, though I will do research later on. By the way, I fell down and cracked my ribs. Ouch. Yes, cracked ribs. No fun. I've broken probably most of mine, some repeatedly. And if you enjoy the content on YouTube, don't forget to press like and subscribe over on YouTube. We've seen, shall we say, a stagnation in our subscriber count, where it's been oscillating between exactly 1,740 and 1,750 subscribers for about 2 weeks now. It's a mystery, and YouTube's credibility is history. But press like and subscribe anyway. We've got the most videos hosted on YouTube, as more videos on YouTube than any place else. YouTube.com/smAsho. Check out our playlists, youtube.com/smashamash/playlists. Approaching 400 subscribers on BitChute, thanks to our subscribers on BitChute. And today we're going to do a short cosmology segment. We're going to pick a random number between 1 and 1031 with our quantum random number generator. And let's enter the 36th chamber. Entry 36 is Fermi J0109 plus 6134, a gamma ray source. There are the X-ray transient outbursts from it. It's got some significant bursts here, like this one that happened in 2019. And let's take a look at J109 plus 6134 on Aladdin Light. You can link directly to that from the Neil Gorell Swift Bat X-ray Observatory. Let's take a look at it on Fermi. And you can see indeed there is a gamma ray source there. Fermi is the gamma ray whatever. I don't know, it's a ground-based system, I would think. Here it is on Chandra, and it's quite a bright X-ray source on Chandra. Here's the multi-mirror project, the XMM Newton. And let's see if it shows up on the 2-mass. Not really, but there's a very bright star here in the foreground. Again, that gamma ray source appears to be a blazar. Okay, there you go. It's a distant galaxy. So that's what it is. That gamma ray source, J0109 plus 6134. Entry number 36 on the Neil Gorell's Swift Observatory, the Burst Alert Telescope. And that's today's cosmology segment. We wanted to shorten it up a little bit. Next, we'll get to talking about electrons. Once I check the life of the stream here, and it looks just fine. The good news, one audio, is that cracked ribs really don't have very much of a treatment, and you'll be reminded not to fall down every time you breathe, cough, laugh, sneeze, etc. I've broken many, many ribs, mainly through snowboarding and crashing on ice. In any case, there's the one-year chart of the electron flux. You can find that at solon.info/solar as well. And electron flux has remained in warning levels here since about 10 o'clock universal time yesterday. So high levels of electron flux here. That's the 3-day chart. And the forecast is for that to continue, so we can expect to see similar levels of electron flux today, maybe even a little bit higher here. I wouldn't be surprised to see this go a little higher, but I would tend to agree with that sort of a region for the forecast. The green boxes are the forecast, and the yellow diamonds are the observation. Here's a visualization of the total electron content. This is the whole air column from about 12,500 miles down to your GPS handset, potentially. And we see the most GPS errors around the equator at noon. Everything looking normal there on the electron content forecast. By the way, the GOES 16 makes its measurement right around here, around 300 kilometers at the F ionosphere layer. And that's why we show the map daily, because we show lots of data from the GOES 16. And here is the ionosphere. And we're looking at the vibrational frequency of the matter therein, measured in megahertz, millions of vibrations per minute. We see some rapid charge-ups over Central South America there, making it to about 13 megahertz, it looked like, just west of the South Atlantic anomaly. And let's bring up the latest image. That's from 9 o'clock universal time. Looking a little bit discharged here, a little bit charged up on the nighttime side in this area, in the Central Pacific. Otherwise, not really particularly interesting. And let's go into the realm of meteorology. So one of the best snapshots that you could possibly take is to look at the jet streams. It'll give you the best possible global weather forecasting capabilities, in my opinion. Here are the jet streams of the eastern world. And we see some extreme meridional jet stream flow in the southern hemisphere here. You see these sharp 180-degree bends. Here are the jets of the western world. And we'll show you the northern geographic pole as well, since we showed you the south. Check it out. We've got a reversed jet stream here over north central U.S. A large portion of the jet stream there blowing east to west. And that has to do with an atmospheric pond. Those are the surface winds, by the way. I just wanted to bring that up real quickly. We've got a powerful low pressure system there in the North Atlantic. And here's the geographic North Pole, and we've got extreme meridional jet stream flow. We've got tripled up jet streams in certain places here. And a jet stream scale anticyclone, this powerful clockwise rotation we see up here. And let's take a look at the surface winds real quick, just for fun. We've got a powerful low near the geographic North Pole as well, right there under my pointer. Some strong winds there in the Arctic Ocean, north of northern Europe. Anyway, there are the jet streams once again. Let's move on. Here are where pressure cells are located, and you can see that low in the North Atlantic. It's actually a double. We're going to advance this into the GFS forecast for tomorrow. There's where we expect pressure cells to be at 12 noon tomorrow. That's Eastern time. And we use Eastern time because that's what Windy displays, and we're located right here in eastern Pennsylvania, something like 12 miles from the New Jersey border in Lehigh Valley, if you were wondering. And thanks to all you new viewers. Thanks to new viewers, old viewers, middle-aged viewers. Next, looking at blitzertung.org to see some significant lightning strikes here in the southern portion of the U.S. Let's zoom in. It's a real-time lightning map. And we see some happening here in southern Alabama, as well as northern Alabama. And we'll give you an idea of where those storms are headed here momentarily. First, the cloud layer. And you can see some spontaneous cloud nucleation happening right here. It's the source of those thunderstorms. They're going to be continuing to move pretty quickly here to the east-northeast, it looks like. Here's a water vapor map, and you'll see those results of sudden evaporation and then sudden rainfall. You can see right here the way the atmosphere becomes dry all of a sudden. That's sudden rainfall, folks. Also, I would note this long band of dry mass of air is largely in control of the separation of these air masses. Much warmer air down here and much cooler air up here. And you can see the result of that reversal of the jet stream creating some odd conditions. Here's a U.S. Doppler map, and we've got precipitation all over the country. Some snow showers in Pennsylvania, as well as all kinds of precipitation falling all around. We won't go further in depth than that, although we will thank our patrons. Hey, patrons, thanks for being the true source of funding for the content. That's why we roll your names daily. Please consider becoming a patron, patreon.com/smashamash. It really helps us out, and it increases the possibility that the videos will continue to exist and remain publicly visible. In any case, wherever you're watching, don't forget to press like and subscribe. Leave us a comment. Tell your friends, your foes, your science noobs, and your science pros about the channel. Here come bonus features. It's the colorized magnetogram and the solar intensity gram. We're going to show you degraded sunspots, if there are sunspots at all. I think we're going to be back to just one sunspot group here. And it's going to be this new one. And it looks like it's only one polarity. Let's take a look. I think there's only one polarity going on there. That would be my first guess. And it's actually not that well formed there. We see sort of a spotty umbra. And let's show a couple more views here. Here's 171 angstroms, the full disk view. Ionized iron. I believe it's iron 9, actually. Again, expect to see an uptick in the radio flux coming in the coming days, folks. Although the sunspot isn't that well defined, and it does appear to only have one magnetic field, so it's going to be an alpha class sunspot, although it is of significant size. There's the magnetogram of that. Here's the 304 angstroms view of that same area. Some great filamentary activity kicking off around there. Again, the likelihood of coronal mass ejections has gone up a little bit, although not all that much, in that it is an alpha class sunspot, at least as far as we can currently tell. Fantastic view of that filamentary activity there. And here is the 171 angstroms close-up of the same area. Again, thanks for tuning in, folks. Remember, stare at the sun, attempt to understand the physics, and when you're understanding the physics, don't drink. But if you do, don't drive. And since it'll never be now again, visit our links. And may that solar wind be at your back.